Okay, so welcome to the wrap-up lecture for embedded programming, and this is the wrap-up lecture for this week here, where I think it's week 4 at this stage. And the four programs that I'm going to look at in this one are going to be the leap year, the grading percentages, the subgrades, and the coins. So we're going to start with the leap year question, which is, particularly for the level that you're at the moment, is a significantly difficult question. So do remember, if you get a question in an assessment that you don't fully know how to do, make sure you write down or attempt the parts that you can do, because you will always get partial marks even if the program doesn't work fully. So in this particular program, you're asked to write a program that will take in a year from the user, and it will try to determine whether that year is a leap year or not. Most people think that a leap year happens every 4 years, but in actual fact that's not strictly the case. Because of the fact that there are 365.23 days in a year as opposed to 0.25, it means that you can't have it absolutely every 4 years, so they have to make a correction every once in a while. They do that by saying that they, if it's on a 100-year, such as 1700 to 1800 and so on, that will not be a leap year, even though it's divisible by 4. However, the exception to that is that on the 400 year they will have a leap year. So it means that basically 3 years out of, or three times within a 400-year cycle where you would have divisible by 4 year, they will not have a leap year, just in order to make sure that it absolutely keeps in line over a 400-year period, which seems an awful long time, but that's how they do it in order to keep it in line. So what that means in effect is that any year divisible by 4 will be a leap year, but not if it's divisible by 100. However, if it is divisible by 100 and it's also divisible by 400, that is permitted to be a leap year. So it's a little bit of a difficult one to try and grasp, and therefore writing the logic for it can be a little bit difficult too. So I've wrote just the body of the function here. I have int main void, I have my system pause and my return 0, and I've made an integer called year. I've made it an integer because we don't want to be able to put in the year 1995.3, because that doesn't really make sense for our purposes. So that's why we're doing it as an integer. Now, what we're going to have is a situation whereby we have to take in the year from the user. So that means then, again, if you're asked an assessment, you should at least be able to do this part, even if you're not able to figure out exactly what a leap year is. So the first thing we do is we ask the user, printf, please enter the year. And then we have a scanf. %d because it's an integer, and we use the ampersand because it's the address of where we want to put it, and we want to put it in year. So that value is now in year. Now, we need to make a decision either that it is a leap year or that it's not a leap year. And there are a number of ways of going about this, so I'm going to do it one way, but you may have come up with a slightly different way that may have worked. But make sure you test it for all the different possibilities. And when I say all the different possibilities, I don't mean that you test it for every year of 2,000 years, but you certainly test it for an ordinary divisible by 4 year, you test it for one that isn't divisible by 4, you test it for one that's 100 years on a 100-year point, and you test it for one that's on 400 year, divisible by 400 years, and check for all of those and see if they come out correctly. So we're obviously going to have some sort of an if, and within that we're going to say printf this is a leap year. Now, of course, what I may find is that when I actually go to write my ifs and my elses, that it's more appropriate for me to say the if and say that this is not a leap year. You know, these can be somewhat interchangeable. But we obviously decide on one, and then for the opposite, if it's not a leap, if it is a leap year in one, so if it's not a leap year, we must say it's not a leap year. There's no need to do any more ifs. Okay. Now, there are other ways of doing this where you may have a sequence of ifs and so on, but I'm going to try and do all my decision making in here. So the opportunities for something to be a leap year. Firstly, it must be divisible by 4. So that's the first thing that absolutely must be the case. It doesn't mean that all situations will be that, but that all situations divisible by 4 will be a leap year, but it must at least be divisible by 4 to be a leap year. If it's not, it definitely won't work. So I'm going to say year percent 4 equals 0. So what that's saying is that when I divide the year by 4, I should get a remainder of 0. If I haven't got a remainder of 0, it must mean that the year is not divisible by 4, and therefore it is not a leap year. Now, is that the only thing I need to know for it to be a leap year? Well, no. It must also satisfy other criteria. So that must be true. It must definitely be divisible by 4, but there are also other criteria that must be proved. So I'm going to put in an and here, so that it has to have something else as well. Okay. So one of the things it must have is that it is not divisible by 100. Okay. So I'm going to say year 100. Okay. And I'm going to say not equal to 0, because I don't want it to be divisible by 100. But the problem is that there is one situation where if it's divisible by 100, it will be a leap year, and that's if it's divisible by 400. So I'm going to write that one as well. Year percent 400 equals 0. Now the question then is, what is the relationship between this one here and this one here? Well, this relationship is an OR relationship, okay? So what I do is I put that in. Now just to explain that, with the OR relationship, either that one or both can be true. So I'm going to put these in brackets first of all, so that we separate them out, because I want that all to be true before I move on. So firstly, if I end up with a situation where my year is divisible by 400, then I'm okay. I really don't need to check if it's divisible by 100. It will, of course, be divisible by 100 because it's divisible by 400, so it can't not be. But it actually doesn't really matter. I don't need to check it. As long as that's true, then that's all that matters to me. Okay. If, however, this one is not true, okay, it doesn't necessarily stop it from being a leap year, because we can also check, what we also need to check is it not divisible by 100? Okay, so remember that we could have a year here that's divisible by 4, and let's take the year 1700. So this part is certainly true, but because we've got an and, this whole section here must also be true. And if it's 1700, this bit is not true, so this bit must be true in order for it to pass. Okay, now 1700 is not divisible, or is divisible by 100, and therefore this part here is not true. So now we have a situation where this is not true and this is not true. Therefore, overall, that section is not true, and therefore, even though it's divisible by 4, this part is not true. So we've this side of the and being true, and this side of the and not being true, and therefore, overall, it's not true, and therefore, we must go down and say this is not a leap year. Okay. Now, if we have a year like 2000, that is divisible by 4, so that's true. We also need this whole section here to be true, and for that to be the case, we find out that it is divisible by 400, and therefore we're fine, and this bit doesn't actually matter at that stage. Okay. If it's divisible by 4, let's say it's 1996, well, that's divisible by 4, that's fine, but we also need all of this to be true. 1996 is definitely not divisible by 400, so that section isn't true, so we need this one to be true. and this is true. The year is not divisible by 100, and therefore we're fine. So in that case, it's okay, and it is a leap year. So that completes it all. Now, one other thing that I'm going to do, though, is I'm going to just put brackets around certain sections here. It's not necessary, but it just means that what you definitely want is this part to happen first. So I'm going to do the same here. Actually, sorry, I'm going to do it differently. I'm going to put it to there. I'm going to put it to there. The reason I'm doing this is, so have we that done? We have one on each. Like that. Now, the point of what I'm making here is that so this one is not actually vitally important because this is the precedence I happen to know is definitely the case. One thing you want to make sure of is that we don't have a situation where we say 0 or year and then go and do something else, right? So we don't want this operator here taking precedence over this one or this one. So that's why we put the things in brackets in order to make sure the order in which they happen. So that will complete the thing. We'll actually just go and test this now and see if it works. So remember to test it for all the different possibilities. We'll firstly test it for 1993, which should not be a leap year. And it says this is not a leap year. So that's working. We'll test it for 1996, which is divisible by 4 and therefore should be a leap year, and it says this is a leap year. That's okay. We'll test it for the year 2000, which should be a leap year because it's divisible by 400, and it says this is a leap year, so that's okay. And lastly, we check it for something like 1700, which should not be a leap year because it's divisible by 100 but not divisible by 400, and says this is not a leap year, so that is indeed working. Okay, so that's the leap year program. Remember to keep things neat as I've shown here. So we've written in our declarations up here, we've written our printf and our scanf here, we've a little space then before the actual bit that we're doing. Make sure with your if statement that you put the bottom brace straight below the if statement like that, not tabbed in here or back out here. Okay, and same with the else into here, and then the brace straight down below it, and then everything inside that tabbed in one space so that we can clearly see inside it. Don't have it back out here because that's then confusing as well. Okay, so that's how you properly indent the code, so make sure you do that in your programs because you will lose marks if you don't. Now, the next assignment that we're going to look at is the grading percentages, and this is kind of part one of a two-part assignment whereby we need to, later on we're going to add plus grades and minus grades to this, but we're going to start with the simple version here, which is just to generate a grades table. So what we need to do is we need to take in a number from the user. Integers is fine, we'll just take integers in from 0 to 100. And we need to determine what grade they're going to get. Now, as you can see here, a fail is anything below 61. In other words, so a 60 is included in a fail. Now, this is an unusual set of marks. This isn't the same as the marking will be done here in the college, obviously, but it's just to put some sort of settings in place for it. So anything from 0 to 60, we're going to give an F grade for. Anything from 61 up to 70, we're going to give a D grade for. 71 up to 80, inclusive, a C. 81 to 90 a B, and 91 to 100 we're going to give an A for. So we'll start a new program here, and I'll just pause while I write the body up. Now, so the first thing we're going to do is we're going to declare a variable, so we're going to call that our percentage. I'm going to call it, I'll just call it percent. So that'll be the mark that'll come in, and actually, I'm going to call it, what I'm going to do is I'm going to call it exam mark because I'm breaking my own rules there. Percent could be used for anything. We're going to call this exam mark because that clearly tells you what the thing does. Okay, so give it a good name. And we're going to do a printf here, say, please enter the mark. we'll do a scanf then. I'll actually take in the mark. It's %d because we're dealing with an integer in this case, and we're going to put ampersand exam mark. Make sure the ampersand is up good and tight against the variable. It can give trouble if it's not. Now, what we're going to do is we're going to have to make decisions, and decisions are generally done by if statements unless you need to repeatedly make a decision, in which case you can use a loop. So in this case we're going to have an if, and we'll start with the first situation, which is if it's 60 or below, 60 or below, we're going to give it an F grade. So if exam mark is smaller than or equal to 60, you could also write that just as smaller than 61. That would do the job. So if it's smaller than 60, then what we do is we say printf and we say grade F. Now I'm going to put a slash n there. Now we use an else, but because there are several other possibilities, we're going to use an else if, and we're going to ask another question. So I'm going to say if exam mark is greater than or equal to 61, can't just do that because obviously an exam mark of 80 or 90 would not be D, for example, so I can't just do that. I have to say and, so it must satisfy both of the criteria that I'm going to put in. The second criteria is exam mark smaller than or equal to 70. Now, one point to make clear here is that a common mistake for that type of thing is that people say, okay, exam mark greater than or equal to 61 and they just write that, and smaller than or equal to 70. They don't rewrite exam mark, and you must do that. It won't understand what you mean otherwise. So we'll do a printf and we'll say grade is, or subgrade D. Do a slash n again. Okay, and they all follow on like that from then on. So we can do a copy and paste. But where are you doing these copy and paste though? Because one of the dangers with them is that you forget to change one part of it, and you start looking at what comes out, and you're not entirely certain what's going on. So if it's between 61 and 70, so the next one, if it's between 71 and 80, and in that case it's a C. Or we can check if it's between 81 and 90, in which case it's a B. And we'll do one last else if, and that's if it's between 91 and 100. Now, some of you may look at that and say, well, actually that's the last one. If it's not any of the other ones, it must be an A. But that's not actually true. Technically speaking, there's nothing to stop somebody entering a mark here that's 105. In which case, you shouldn't really print out anything for that. It's a mistake. Now, you could certainly print out an error message, in which case, and I might even do that here just to prove the point. I'll say else printf invalid input or invalid mark. Just in case the user might do something incorrect. So let's give that a run and see that it works. There may be one or two mistakes. There often can be. So we'll save it first, and I'm going to save it here as grade C. Make sure to call it .c, and we'll run it there. please enter a mark. I'm going to put in 78, and it says that that is grade C. And if we just check that back in our thing, 78 would indeed be a grade C. Remember to check, I won't run through all of them here, but for yourself you should really check whether it does all the different possibilities. So do things like check 80, that's coming out as grade C. Is that technically correct? Yes, it is. 80 is covered by C, and so on. Okay, and obviously check one of the ones that's going to be a fail as well. So 45, that comes out as a grade F. So we'll assume that that's working there. It certainly looks correct, but you should really check all the possible values there when you're going through it. So that's the grading percentages one, and what we're going to do next is we're going to look at the follow-on to that, which is the subgrades. So back to the assignments here. And what we have to do is we have to modify the previous program to print a plus or a minus after the letter grade. So for numbers 1 to 3, we put a minus sign. For numbers 4 to 7, inclusive, we put nothing. So you just get, if it's a C, you get just a C. You don't get a plus or a minus after it. And for numbers 8, 9, and 0, we get a plus happening. Okay, you might wonder why is the 0 there. Well, it's actually because that's at the top end of the thing rather than at the bottom end of it. So the first thing that people jump to immediately here is that you're going to have to write else ifs for each different possibility. That's actually not the best way to do it, because if you look here, if I take out, we can only have pluses and minuses happen for these ones here, so just take them out. So if I run that and I put in 67, it'll say grade D and it'll have nothing after it here. What I can do is I can make sure that the next printf that I put in puts a minus straight there, and I'm going to just show you that. Down here I'm going to do a printf with a minus. And we'll run that and say 89, and it comes out as B minus. Now, of course, 89 is not a B minus, so that wouldn't work just on its own, but it does just show you how the minus will appear straight after the last thing that you did. So, what I'm going to do here is I'm going to do and firstly, what I want to do is I want to find out just what the lower digit is. So I don't care if it's in the 70s or the 80s or the 90s or the 60s. I just want to know what the lowest or the least significant digit of the thing is. Now I do that by, firstly, I'm going to make a new variable. Not strictly necessary, I could do it another way, but I'm going to use a new variable called subgrade. And down here I'm going to say subgrade is assigned exam mark, and I'm going to say %10. And what that's going to do is it's going to divide exam mark by 10 and give me whatever the remainder is after that. So it doesn't matter if it's 63, divide that by 10, the remainder will be 3, and that's what will go into subgrade, and that's what will get checked. So, and of course you've seen that modulus operator, remainder operator used many times now, so hopefully you know what it does at this stage. So we'll do an if, and we'll check for the first possibility, which is the minus numbers, and the minus numbers happen if subgrade is greater than or equal to 1. I'm going to have to check this again in a second because it's not, I haven't remembered it in my head. If it's greater than or equal to 1, and I'm just going to put brackets around this just to be safe, and subgrade is smaller than or equal to 3. Now I'm just going to check that that's definitely correct, because yeah, between 1 and 3, 1 to 3 inclusive is a minus sign. That's okay. So in there I'm going to print out just a minus sign and then a slash n, so we go on to a new line at that stage. Else if subgrade is bigger than or equal to 8 and subgrade is smaller than or equal to 9, and we can add a third one here, which is or. The other option is that if subgrade is equal to 0. So there are my possibilities. And what I'm going to do is I'm going to put this section here in brackets so that it does that bit first. It checks is it between these two values. I could strictly speak and put it, change it to the. Well, I'll leave it at there for the minute, and I'll show you one other possible way of doing it. As I said, there's a number of ways of doing many of these things. So again, I'm just going to, for safety reasons, put brackets around this section here, and that section there. It's just for I don't want that 8 to be ANDed first with subgrade before it does anything else, because obviously the subgrade has to be checked for being smaller than or equal to 9 before we then AND it with something else. So it's just to make sure that it goes in the right order. So for that we print out a plus. Slash n. Probably no need to put an else here, but I'm going to do it anyway. And I'm just going to put in printf slash n, because we're not actually printing anything for the other operation. It's not a plus or a minus, it's just nothing. Okay. So we'll just run that and try it, and I'm going to say 85, and that's just a B, and that's correct because it's not a B plus or a B minus. I'm going to try 88, and that's a B plus. I'm going to try 82, and that's a B minus. I'm going to try 80, and that's a C plus, and that's important. It's not a B plus, obviously. It's a C plus because that's the very top end of a C. Okay, so all of those seem to be working, and we can try it for obviously the different numbers. There's one worrisome one though, and this is something that you may not have actually included in your program when you were submitting it, even if you got this one right, and that's what happens if I get 58, and we can see that I've got an F plus. Okay, and the plus has gone down here because I still have a slash n up here. Okay, so I can run that again just to prove it. I can say 58 gives me an F plus, and there's no such thing as an F plus. Okay, so what I can do is I can take this whole section here and only run it if my exam mark is greater than 60. And I do that by saying, putting an if statement here and saying if exam mark is greater than, I say greater than rather than greater than or equal to, because obviously I need it to be 61 and above. So if it's greater than 60, we're going to do all of this. Now that means everything else getting tabbed in one place in order to keep it neat and tidy. Okay, so that now I can see straight onto the if is the closing brace for that if, and then everything else is inside in that. If you want to leave a little bit of a space here and a space here just to space it out a bit, that's fine, but that's effectively the section that's inside this if statement, and so it's covered by exam mark being greater than 60. Let's give that a run just to prove it. So I'm going to say 58, we just get an F, okay, and you'll notice there that no slash n has actually happened there, so that's because I'd gotten rid of it here, so I'm going to put it back in there. and just prove it. So 58 is an F, and then we'll try some of the others. I'm going to try, let's say, 79, and that's a C+. So we can see that that's running now. Okay. So that's the subgrade section, and you can see we split it up into the grade section and the subgrade section, and that's important because otherwise you'd have to deal with the situation of an F and then deal with the other 4 situations by 3 possibilities, which would mean 12 if-else statements, whereas this is a much neater, quicker system for doing it. Okay. Now this brings us on to our final program for this wrap-up lecture, and that's the coins program. So we're given an amount of money, less than €1, and what we have to do is we have to compute the minimum number of 50 cent, 20 cent, 10 cent, 5 cent, 2 cent and 1 cent coins required to make up the amount, and we need to print out the list of coins as we do it. So again, I'm just going to write the body of the program and then we'll take a look at it. Now, so we have to take in an amount of money less than €1, so I'm going to do an int for money. Obviously we don't want to have a fractional amount of money, that wouldn't make sense in this case, so printf enter the amount of change to be given. Scanf and I'm just saying I've actually written that as enter the amount of change to be given, so maybe I should call this change rather than money, although either would do really in that case. So I'm going to say %d, I'm going to say ampersand change. Now, what we need to do firstly is find out how many 50 cent coins are in it. And so what I'm going to do is I'm going to make another variable called coins. And I'm only going to need one variable for that. I don't need separate ones for 50 and 20 and so on, because I can actually reuse them. So what I can do is I can say coins is assigned money percent. Or sorry, I said money, it should be change. I knew that would come back to bite me when I went and changed it from what I originally had. Coins, not coins, 50. Now, so what I'm saying here is that you take the amount of change you have and you divide that by 50, and however many times that goes in, that's how many 50 cent coins you can make out of it. And obviously you start with the largest denominator coin because that's what you would normally do when you're giving change to somebody. So clearly, the most amount of 50 cent coins we could be giving out is 1, because you know, if it's less than €1, it must be at most 99 cent. I'm going to say the amount of change to be given less than €1, just to make that clear to the user. If any of you have tried to actually get the euro sign to print out or anything like that, that won't work, I think, for you, because there's no ASCII character for it. So that's coming out there. We'll see if that actually prints out. I have a feeling that it won't, but we'll see in a moment. Now, so coins equals changed percentage 50. That'll either come out as a 0 or a 1. So we'll say printf I would say percent d 50 cent coins. And I'll put this bit in brackets here so that you can say coin or coins /n. Like that, and then obviously I have to say what's going in there, and it's coins is going to go in there. So we'll just check that first and see that it runs okay for us. So I'll just save that as coins. See, and you'll see there that the euro sign has not come out correctly because it doesn't exist as an ASCII character, so that's what's wrong there. That's fine. So I'm going to put in 97 here, and it's going to say, it's saying 47 50-cent coins, so I've made a boo-boo there because I've been thinking ahead to what I'm going to do, and I should have actually put in the divide sign there. Okay, so you'll see the percentage sign will come up in a moment or two. So that should have been the divide sign, because I just want to find out how many of them, how many 50-cent coins are in it. So it's definitely not 47. So 97 is what I'm going to put in there, and we see that there's one 50-cent coin in the change. But that brings us on to the next section, which is what I'm going to do is I want to find out then what's left after I've taken that 50-cent coin out of it. So if we use the example that I just had there, where I had 97, if I've taken a 50-cent coin out of that, that's going to leave me with 47 cents, and that's what I need to use to then decide how many 20s I'm going to take out. If I simply did coins is assigned change divided by 20, the problem I would have is that we'd be starting with change in my previous example being equal to 97, and 20 would go into that 4 times. So I'd be giving out one 50-cent coin and then 4 20s, which we wouldn't want. So instead what we do is we say we get change or percent 50, and that will give me the remainder left over after dividing by 50, which is what I was doing previously where I shouldn't have been doing it. And I'm going to update change with that value, so I'm going to say change is assigned that, so that now it will change in my example from 97 down to 47. We'll then do the divide by 20, so 47 will be divided by 20, and that'll go in twice, and then I'll print that information out. $0.20 coins, so we'll just try that. So 97, obviously one 50-cent coins, two 20-cent coins, and that's working so far. We'll try it for something smaller. We'll say 39, and we've got no 50-cent coins, one 20-cent coin. That seems correct. So what I can do is I can copy this section and reuse it with different numbers in there. So obviously next time what I do is I get the remainder of what's left after I divide by 20, and then I do a divide by 10, which is the next lowest denomination, so that's 10 there, and we'll do all that again for the 5 is the next one. So we do a modulus 10 or remainder 10, and then do a divide by 5, and then we say that many 5-cent coins, and again. So this time it's after 5, and we do a 2, and that's how many 2-cent coins we're going to have. And finally then we'll take that section then and do this for the 1-cent coins. I just need to look at that because I think I haven't changed everything. So this is the 20, we've done a divide by 10, that's given me the 10-cent coins. The modulus by 10, and then divide by 5 I should have done here. And then in the next section it's modulus 5. I think I changed that and I didn't get rid of the 0. And then we divide by 2, that'll give me the number 2-cent coins. Then the last bit is then do that by divide by 2 and get the remainder. And then we don't actually need to do the divide by 1, because that wouldn't really make any sense. It would be divide by 1. We can just put it as change, and that gives me the number of 1-cent coins that are left. And we'll just try that and make sure that it works. So I'm going to do 97. Okay, so we've got 50, and we've got 2 20s, so that makes up 90, and then we've got a 5, which makes up 95, and a 2, which makes up 97, so that's okay. I'm going to do 98 just to see that I include a 1-cent coin in it. 98, and it does indeed. Okay, and then I'm going to do something like 88, so then include a 10-cent coin. So we can now see we have a 50, a 20 is 70, 80, 85, 87, 88. That's fine. And we'll try something lower. That's just something like 13 here, and that's a 10, a 2, and a 1. So that's all working there, and that's the system of how you do it. A lot of you may have tried things like if statements and so on, and minus signs rather than using the modulus and so on. There are a few probably ways of doing this, but this is probably the most efficient. Okay, so that's it for this this wrap-up lecture, and I hope some of those programs have helped you out. I hope you got them the first time, but if you didn't, I hope that has answered the question about how this should be done. Okay.